Hello everyone, today I am thrilled to share my project, the gift recommendation system. This project was my submission for a coding challenge and the goal was to create something exciting using a dataset of Amazon Find Food reviews, a treasure trove of over 500,000 food reviews. The mission? To build a Flask application that takes user inputs like the recipient's preferences and recommends the best matching products. Sounds exciting, right? Let's dive in. But first, let me show you a quick demo. Here's the homepage of our application, designed to warmly welcome users. Upon clicking Explore Now, users are redirected to a form. This form asks for inputs like who is the recipient, what are the interests. After submitting the form, the system provides a list of best matching gift options. This is all based on a technique called content-based filtering. Let's unravel how it works behind the scenes. First, let's take a look at the code in the notebook where the magic begins. Here's what's happening in simple terms. We start by importing essential libraries like NumPy and Pandas. The gdown library downloads the dataset directly from the Google Drive. This is there to keep the notebook clean and clutter-free. Next, we download and load the dataset. The dataset is fetched and read into Pandas data frame. We then clean the data by removing any missing values and ensuring all rows have valid numerical data. Here we group the data by product and create a summary text for each product. Scores are averaged and helpfulness metrics are summed up to ensure comprehensive data. This function removes stop words and punctuation and stems words for simplicity. The result is clean, processed text ready for analysis. We use TF-IDF to convert text into numerical vectors. These vectors are what the system uses to find similar products based on user inputs. Finally, I saved the processed data, vectors, and vectorizer into pickle files for reusability. Now let's look at the script where we bring the recommendation engine to life. We load the processed data, vectorizer, and vectors from the pickle files. The recommend class is where the core logic resides. This ensures the recommendation engine is modular and easily reusable. And this is where recommendation process happens. We take user input, clean it, and transform it into a vector. Then we compute the similarity between the input and all products. The top 3 most similar products are returned. Finally, we fetch product details using an API to make the recommendations more visually appealing. This step ensures the system provides users with not just product IDs, but detailed descriptions, images, and prices. To make the recommendations more useful, I have integrated an API from Rapid API to fetch detailed information about Amazon products using their product IDs. This gives us titles, descriptions, prices, and even product images, making the results visually appealing. Our application uses HTML templates for the user interface. These templates are stored in the templates folder and define how each page looks. In addition, we have static files like CSS and images. That ensures our web pages are beautiful and responsive. Together, they provide a seamless and engaging experience for users. The backend of our application is built using Flask, a lightweight web framework. Let's go through the main code step by step. Flask handles web routing and rendering templates, and these classes power the recommendation engine and API integration. This route serves the home page, and this route serves the form page where users can input preferences. User inputs from the form are combined into a natural language prompt. This makes the system flexible and user-friendly. We use the recommend class to get product IDs. The product details class fetches additional information for these IDs. If the API rate limit is exceeded, a custom rate limit page is shown. For other unexpected errors, an error page is displayed. If the rate limit issue occurs but we already have recommendations, the product skips the problematic requests and continues. If no valid products are found, a message informs the user. Otherwise, recommendations are passed to the recommend.html template for rendering. Here's how recommendations are beautifully rendered on the result page. This loops through all recommended products. Each product's image, title, description, and price are displayed dynamically. The classes like product box, product image come from the static CSS file, making the layout visually appealing. And that's it. In this video, we explored the gift recommendation system from front to back. understood how user inputs, machine learning models, and API work together, saw how Flask powers the backend and how the results are rendered dynamically. I hope you found this walkthrough informative and inspiring. Let me know your thoughts or questions in the comments. So that's it for the video. Bye, and I'll see you in the next one.